All right, so here we are, Unit 2, talking about similarity and congruence. So like we've mentioned before, after translating a shape, rotating a shape, or reflecting a shape, you get a congruent shape. After dilating it, you get something that is similar, but no longer the same. The only the biggest difference between similar and congruent is the side lengths. At the end of this unit, we will be writing proofs to prove that two shapes, triangles, are similar and two are congruent, and we have to be able to back that claim. So that's what we have right now. But before we get into that, we do have to establish there are a lot of rules that we have to learn first. We actually call them properties, postulates, and theorems. We should be able to kind of pull these out of that 6th grade math that we learned, that 8th grade math. A lot of this stuff, again, is already learned. We're just using it in a more advanced way. We are going to start off learning this week, 2.1, reviewing what we already know, talking about angle relationships, and then talking about parallel lines and transversals. So these are angle relationships. These vertical angles are angles that are across from each other and intersect, and they are always congruent. So any two lines that cross are vertical. I'm going to go in a counterclockwise pattern because that's how we should do math. Then we have adjacent angles, where two angles are next to each other and they share a common side. That just means they share a wall. They share some kind of ray in between where they are. So I have angle ADB and BDC to create angle ADC. Those two are adjacent because they are next to each other. Vertical means across, adjacent means next to. I have complementary angles, like we mentioned before. Complementary angles add up to a 90-degree angle or a right angle. So our example here is a right angle because complements make you feel all right. We have our right angles, 90 degrees. If it makes a 90-degree angle, A plus B equals 90 degrees. Thank you. That's how that works. And then we have our supplementary angles. Supplementary adds up to 180. So, two angles whose sum is 180. This is kind of what I wanted to get to before. Supplementary angles add up to 180. They do not have to touch. So we have our supplementary angles because 110 plus 70 equals 180. If I were to take these two angles and put them together like two pizza slices, I'll say slices, pizza slices, it would equal it would equal a straight line. It would create half of a pizza. If somebody really didn't know how to cut pizza and cut it all funky. Or maybe that one didn't get cut all the way. Anyway, doesn't matter. That is our supplementary angles. When the supplementary angles are right next to each other, just like they are in that example, they are considered a linear pair. So I liked this example because it did separate supplementary from linear pair, because not all supplementary angles, as we've discussed and will discuss in the upcoming units, not all of them are next to each other. They're not going to be consecutive, like adjacent all the time. So here we go. These are all of our definitions. I think all of them. These are our definitions for this part of the unit. So our parallel lines and transversals vocabulary. These are the different things that you need to know. So we have our transversal, the line that intersects two or more lines, two or more parallel lines at two different points. Exterior, outside the parallel lines. So these are all definitions and rules that come up that we use to prove certain things are the same or different. Here we can start with our corresponding angles. Corresponding angles, long story short, are in the same location. So as long as I have, like if I'm talking about my top right corner, I'm going to be talking about my top right corner in the other one. Top left and top left are also corresponding angles. Bottom left, bottom left, bottom right, all of those are corresponding angles because they are in the same location. The math part of this that makes it actually kind of interesting is that someone had to draw this out however long ago. I don't know who, I don't even know who like actually came up with this, but someone had to sit there and go, well, wait, if it's the same line just translated down a little bit, hint, hint, parallel lines, same line, just translated. If it's just translated down, doesn't that mean that it's the same line, so the same part is going to be equal? So they measure it, they prove it, yes. So we would say that any corresponding angles are congruent. They are equal to each other. If this up here is 120 degrees, well, this down here is also going to be 120 degrees. There's not going to be any leeway in that. They're the same if those two lines are parallel, if and only if those two lines are parallel. Next, we have alternate interior. Alternate just means on the other side of the transversal. I have one on the left, one on the right. Interior, like I mentioned before, means it's inside those two parallel lines. So we look at the two angles and say, are they on opposite sides of the transversal? Yes. Are they inside the parallel lines? Yes. Then those two angles are, in fact, alternate interior angles. Alternate interior angles also happen to be congruent. Looking at them, knowing that they are equal to each other, if this one is 30 degrees, this one has to be 30 degrees. It's going to be consistent no matter what, so long as they are two parallel lines, if and only if. All right. Next, we have the opposite of that, so alternate exterior. So again, opposite sides of this transversal and on the outside of our parallel lines. So I have bottom left, top right. Those two are alternate because one's on the left and one's on the right, and they're both outside the parallel lines, so it is an exterior angle. Those two angles are also congruent. That being said, if this was 150 degrees, this one down here is also going to be, you guessed it, 150 degrees. They're the same angle, just different locations. Well, actually, it's the translation of the vertical angle, but that's all. We'll get to that. So yeah, if you see two angles in those positions, they are also congruent. Our supplementary angles, we have two or more angles whose sum is 180 degrees. They do not have to be next to each other. So yes, I understand that this one shows it to you right next to each other, but these two right here, because we know that these two are the same, this inside left and inside up here, we know that those are the same. So these two are also supplementary, even though they're not next to each other. When they're next to each other, you can consider them a linear pair, but supplementary angles do not have to be adjacent, if you know what that means. They don't have to be up next to each other. Our next one is vertical angles. I always say that the vertical angles always look like a bow tie. So it's like on one side and the other side. If it makes a little bow tie, they're vertical, and vertical angles are also equal to each other. Oh, I forgot. Not congruent equals 180, and then vertical angles are in fact congruent. They're equal to each other. And that doesn't only happen with parallel lines in a transversal. That happens with any line that crosses any other line. If you have an angle on one side, it's going to be exactly the same if those lines are straight to the angle on the other side. Our last one, but really should be two, but they didn't split them up that way, are consecutive interior and consecutive exterior angles. So we have our consecutive interior, which means, or consecutive means same side of the transversal. They are both on the right, and they are inside the parallel line. So they're consecutive on the same side inside those parallel lines. Or consecutive exterior means it's on the same side of the transversal, and they're outside those parallel lines. Looking at these, you can automatically tell they are not equal. One is obtuse, one is acute. They cannot be equal. So we discovered that they are not congruent, but they are supplementary. They are equal to 180 degrees.